here is the sine double angle formula that we've been using so far. And in this video we're going to take a look at how to prove it, and it actually turns out it's quite easy to prove using some old formulas that we've seen in the past. So what I'm going to do is begin with this and end up over here with what we've been using as our formula up till now. So I'm going to begin like this. Rather than writing sine of 2 theta, I'm going to write that as the sine of theta plus theta. It's the same thing, right? Just like x plus x is 2x. So theta plus theta is 2 theta. And then using our sine sum formula from the other day, and if you need to go back and watch that video, go ahead and do that. That formula that was the sine of a plus b, I can go ahead and break this formula apart using the same idea we've talked about before. It's just our a and b are both going to be theta in this case. So what that formula said was it was the sine of a, which is theta in this case, times the cosine of b, which is again theta, and then plus the cosine of a, which is again theta, times the sine of b, which is again theta. And so what I end up with are these two pieces. And remember, it doesn't matter what order you multiply things in. So I could switch around the sine and cosine of theta if I wanted to. And then it turns out I have like terms. I've got one sine of cosine, or one sine cosine there, another sine cosine there. So altogether I have 2 sine cosines. Okay, and sure enough, that's the formula. So the proof is really that kind of straightforward. In your homework, you're going to be asked to do a similar thing to prove the cosine of 2 theta formula. But again, follow the same thinking, break it apart into theta plus theta, and you should be able to prove it without too much difficulty.